Johansson. My name is Oscar Vos. I'm founder of krft Architects together with Thomas Dieben, and we're we're having our office in Amsterdam. I myself in the northern part of Amsterdam, and we have our practice since 2008. Right in the middle of the crisis we started, so we grew slowly, and we have been learning a lot since then. That's also what I want to shortly talk about, but mainly I want to talk about maybe a different angle. I mean, there's a beautiful series of lectures, and I hope to give a slightly different angle to it, since we have a certain belief as an office that if you can combine challenges or urgencies, then you should try it. That's mainly the main focus of my story. I will quickly start because I have too many slides, and I hope I'll make it in time, so that there will still be some questions. You could also put them in the chat, maybe. We won't forget it. Okay, let's start off. A different story about the benefits of timber buildings, because many of them we know, of course, like the contribution to the decrease of CO2 emissions and nitrogen. Diminishing biodiversity is a key theme, especially in the Netherlands, but of course globally, and a growing scarcity of resources. So, okay, that's the good news. We know how much timber can do in those challenges, which is not unimportant. But next to that, we as Craft believe that the life cycle value of timber buildings, and therefore circular buildings, that's how we approach circularity as being first place regenerative buildings, is higher compared to a traditional linear carbon-based building. So therefore, the upside should fuel an increase of affordable housing for lower middle incomes, social and circular. That's the statement we want to talk about, because we need to act, and we know it. We know it for a while. The limits of growth. Maybe people have not fully read it, but know the Club of Rome and this publication and their future. How do you say it? Precasts, not a truth, but a precast of what will happen if we continue living like we do. And by now we know better than we did before, even how urgent it is that we are starting to transform our way of living, our society. But at the same time, so that's the climate part. And there's a huge, not only in Amsterdam, but on a global scale, there's of course a huge pressure on inclusiveness in cities and affordable housing in general. So the right to dwell is important, and we again see in Amsterdam families moving out of the city, which is at the end of the day bad for the city and bad for the total the municipality as such. But I'll get back to that later. This is a first very, very important start of the lecture, but I want to move on slightly with an introduction about me and well, also about our office. It's not important. I mean, I am my office, and my office shapes who I am and what we do together. I go pretty quickly because there are many slides, but I really want to show you our first project, which is Dutch Mountain, where we had a huge ambition on sustainability. Still getting to learn what that would mean for us. So we've used local materials. You see here the local wood from het Goois Natuurreservaat. We built an energy neutral house, half underground. You can see the solar panels. But still, of course, there's a lot of concrete in it. You could say, okay, that's key because we were building underground. Fair enough, but it still itches a little. But therefore, we made that statement that the former car of our client was put on the wall. It was not allowed to drive anymore, since it, well, you can understand how much fuel this kind of car uses. We learned, and we had an idea with building this house. It should be an open building, passive, solar, local materials, but still, I felt unease about the amount of concrete. So we moved on, and researching what kind of structural materials or structural timber you could use building houses. This is my first encounter with Steko. It's an artist house close to Belgium. We build. It's a beautiful material. You can by hand stack modules, but still learning by doing. It's limiting in its architectural manner. It's time consuming. It's expensive. But it is a timber structure. So that was the next goal for us, trying to be as sustainable as possible in that sense. We try to do that in our public buildings. That's a big challenge, which is still also lying ahead of us. So introducing as much timber as possible, yes, but still there are structural and sound demands which end up being a huge challenge. We keep on learning by doing, but we want to do better. But we try to introduce timber in different ways as much as possible. LVL kind of structures, and where the biggest impact is, I will of course get to that later on, is in housing, since that is a bigger part of our construction in the Netherlands. So if you want to go for impact, you should do that through housing. This is a project which is still not built. It's a very complex procedure, but the design is finished. It's a building in Westerpark West. It's 12 layers, where we call it a sort of Tetris game, as you maybe saw here. So we try to make as much diversity in housing as possible in this tower, making it a CLT or a frame structure with CLT floors, but actually Holzbeton, so a prefab combination, precast combination of the concrete onto CLT, which has its benefits for sure. We see here the facade of the mid-rise block. It has its benefits, of course, but it still needs a lot of concrete in the detailing. That's of course the big challenge still in high density housing. We did a project in Amsterdam, Vuurtoren Eiland, just to show you what you can do with wood. Yes, I'm going through this, but it's an amazing project. We've actually took up the whole island in a new energy system, which you can't see anymore. But we also made this Shishuguban treated wood shed, which is actually the heart of the island, since all the installations are actually within that shed. So it's the beating heart. And you can see here a close-up picture. It's amazing. It needs a lot of treatment, but it's an amazing traditional Japanese, of course, way of protecting the wood. Going through it, I would recommend you going by boat to the restaurant any day. It's beautiful. A project we're working on. It's a school just above Amsterdam. It's a school for kids who have several different learning problems, physical as well as mental. So it's an important building for us, and everybody agrees that it should be built in wood, since that is the best way of creating an environment where they can be at ease and they can be themselves. So we've researched. It's a combination of different ways of different timber structures. So this is Lignature. It's a Swiss company actually, which only is the only company which has this product. It's a beautiful product where you can integrate everything, every demand you have, every performance actually you want a floor to achieve. Where acoustics is of course really important, where you see the Schallschutz. You need mass in a floor to achieve that. So you could put it on top, but why not integrating it in this hollow structure? You can also integrate acoustical elements. So therefore, if you don't have a lot of duct work, for example, you can use those floors. But otherwise, we use in other parts of the building CLT, which everybody knows the term. It's funny to show, but maybe I mean it's going around, so people have maybe seen it. But it's amazing to know that it was actually the concept of CLT was already patented in 1923. You can read here by Frank J. Walsh and Robert L. Watts. It's just the thing was that they didn't have the production techniques of scaling up, of how to make it properly, but the concept, the structural concept, was there. We are happily now in an era where we can and we are scaling up, and it learns us different ways of using a material, and every building, roughly every typology, could maybe use or could make use of different ways of structurally detailing. So these are prefabricated, I call it double T elements. The KLH, it's a company, makes ribs. You know, in some cases, these are amazing products to use if you have big spans. But then again, they're also quite high. So you also need enough floor height space, as well as with these LVL beams. They're structurally amazing, but you need height, but they're very slim. So I'm just showing you what our learning curve was, you need to research all those different opportunities which timber has. The bigger part probably we know by now, but it still is not common enough. So that's why I also see it as a sort of a mission to tell everybody what the opportunities are and to learn from others, of course. So I mean, just put next to each other different typologies and their pros and their cons. That's what we do in every project. And funny enough, I noticed that in our practice we communicate more. I mean, structural engineers are key, of course, but we communicate basically more with the suppliers or the structural engineers of the suppliers to have a very quick feedback loop on designing, and it's very learningful for us as an office and for myself. You see here some interior images of that school where you see the Lignature elements having those perforated down parts, which is a huge acoustical performance. See here a classroom. And in Speelleerplein, as we call it in the Netherlands, it's a sort of also a Swedish model where you, I shouldn't dive into that too deep, but where kids can play and learn together. So you create a space which is challenging to move and to learn at the same time. So really combining those things. I move over shortly to my my own house, where because a few years ago we hadn't built with CLT yet, so I needed an experiment. So I did the experiment on myself, and built with a few families a co-housing project in the northern part of Amsterdam, where I also wanted to challenge myself and my neighbors to create affordable CLT houses, although spatially inefficient, but basically pretty affordable. And that means that you have to design listening to the material. Then again, if you need some proper space, you sometimes introduce some steel, but just to show you that there are projects enough, of course, which is growing the amount of projects using structural timber in the new productive way. And it's easy done. These were my two daughters. Sorry for showing this, but we enjoy to play kapla, and actually, it's really inspiring playing with that. You should do it sometimes. So I move on to another project, which is it's very new, very fresh for us. It's a really tiny project, 100 square meters on a very special small island just above Amsterdam. But the cool thing is, because it wasn't on an island, we had to challenge ourselves to build very light, very smart. So it's 100% wooden, well, HSB as well as some CLT combined house, which could be transferred over on a small boat over the water, which has a beautiful detailing of flaque noir, untreated actually, but cooked wood. Let's say thermally thermisch gemodificeerd, thermally modified wood. You see, it's totally, so as well, the roof as well is totally covered with this durable wood. Creates a beautiful place. But again, going back to the main theme about the fact that timber buildings and the upside of the life cycle value should go into something valuable, namely affordable housing. So I want to move on to talking about a case study research, social circular we are doing with IGG bouweconomie. It's a building economics, building cost calculate office, and Copper 8, specialized in circular business cases, circular economy. Jordi van Laar at IGG is an amazing guy who knows everything on circular business cases. To give you a more detailed list of urgencies, which is important in this research, because we really want to focus on the Netherlands and on the shortage of affordable housing, and really want to show or talk or debate on the fact that we should get rid of the cradle to grave mentality in housing specifically, but also aligning with the national agendas for the grondstoffenakkoord, which is the resources, the climate, and the transition agenda. There is an agenda moving from linear to circular. Want to achieve 100% circular building economy into 2050, which is a serious ambition, but yeah, it should be possible. In general, the construction economy in the Netherlands is responsible for 50% of the use of resources, and social housing is 30% of that. So imagine the impact if we, and then I'm only talking about social housing. With affordable housing, I also mean the mid-incomes, of course, but this is a very concrete target group, the social housing companies. Imagine if they could transform, what kind of impact that would have, and we need to push that. We need to push the upscale. But it is at the end about the business case. They have a huge responsibility and a huge challenge. So it begins there. Because explaining why we should do it is not difficult, but it's about the how. I want to check on how we are doing in time. Okay. So this is a scheme. I actually have it from a master student, Lucas Pracht, who does research on this specific topic, the transition from linear to circular. And he handed to me this great scheme where on the left, let's say you see a traditional scheme where it looks like a network, but it's not activated as a network. It's still very linear. So we have this very traditional chain of a client and maybe an architect, maybe a main contractor, and then subcontractors, suppliers, which is not perfect. Let's put it mildly. And so imagine, and we see it happen, and I guess many of you are listening also see it happening, is that we are moving towards, and we should move towards a more ecosystem structure, circular value system, where the different partners in this scheme can interconnect directly way more. It makes sense. So give a very simple example, or I already just told you now. I mean, when we design a timber mass timber building, it's pretty obvious, or one of your first steps is to call the supplier. He knows exactly what his product does, and he has a huge impact on the whole building, because the bigger part of the building is the structure, and he can give you direct input. So not to literally cut out other parties, which does happen, and which is not a bad thing, but it's not the goal. The goal is to make better buildings, and a ecosystem, a proper ecosystem, will help achieving that, or is crucial to achieve that. So I'm not only talking about suppliers. I'm also talking about the mining companies. The mining, as in urban mining, as in tearing buildings down means resources, means value. These parties are also key in a circular economy, but my focus is mainly on regenerative elements. So let's go short and say timber. So what happens in a circular building environment? Buildings become material banks. Makes sense, does it? So you have your materials stored in a building, and maybe after a certain life cycle, after the total life cycle, that's not the case anymore in that sense, but if you could remount it in any way. But what's more interesting is if you see, it should be housing companies, woningcorporatie in Dutch. He owns a lot of buildings, and if all those buildings are material banks, circular material banks, and it's easy to for the maintenance to take out elements and put them back and share them in this bigger picture between all those buildings, it makes sense for the business case, specifically for housing companies, social housing companies, since they own and they keep owning for the total lifespan of a building, the building itself. And therefore you see happening that social housing companies are really interested and keen on transforming their business case. It's difficult since they have a lot of property which isn't circular. So it's a huge challenge, but everybody can see that the business case makes sense. We'll get back to the business case later. It's maybe not about designing, but a good architect, I think, also is very aware of the business case. We say that for us, making a circular building also starts with some design principles, which is, of course, the Stewart Brand approach of having the 6 layers, which have different life cycle. So take the site, it's the longest one, and you can imagine all the other ones have different life cycles. I'll get back in the scheme on that later on. And overall, in our whole office, we are very aware of the opportunities which open buildings have It might not always make sense, but in general, actually, definitely it makes sense. Even the debate on, okay, does it make sense in housing itself? Because those houses tend to change hardly. It does make sense, of course, to make a structure which is open and adaptive anyway. And what I told, we start always by checking, can we build with timber? Let's make it simple. If not, can we work with materials which are reusable? If not, can we work with recycled materials? This is as if it were such a simple step-by-step thing, but to give you a short insight on how we try to achieve the best or the lowest footprint and how to start in a project. So this is the Stewart brand scheme made concrete in 50 years. It's not a lifespan. Well, let's call it a 50-year lifespan. It's a bit of a traditional approach to 50 years, but anyway. And you can see that you, in general, looking to the business case, you say, okay, the site is endless in that sense. So it's the 50 years, as well as the structure. But it starts with the skin, where you say, okay, so I'm talking about the cladding or the outer layer of a building, which has to endure quite some things. It might need maintenance or changing elements after an update after 25 years. So halfway through, could be earlier, could be later, but this is a principal scheme. And if you talk about the services, it's slightly more often. Now, spatially, it's about the function. So function changes. That's where the adaptivity of a building is key. Might occur way more or way less than what's happening here. And the stuff in it is separated really from the building, of course. It's in Dutch again. I'm sorry for that, but to make it very concrete. So here, translating mutations from housing differentiation, so typologies, because a certain demographic or economical changes could mean the functional end of life for certain components. Shouldn't be the technical end of life, but the functional end of life. You also have, and that's also tough in the skin and also in services, you have updates, of course, by law. So you have a different performance you need to achieve, which might mean that you have to make changes in your building, which you should be prepared for. Well, that's the same as this for skin and surfaces, just to give you an example. So I think I have to be aware of the time. I think we have until 9:30. The case study is on, these are two social housing blocks, and we call it framed as a concept. So we work from a spatial framework, which is exploded, shown here in so the reboundability, the losmaakbaarheid, as we say, is a beautiful Dutch word, is shown by elements. And it's specifically important to imagine having this strategy in social housing, because they could change over to other projects, and they could store it, but they could also just change out different materials throughout different projects, which makes it one big ecosystem in itself. Then by design, making it smart means adaptable, which means as free as possible floor plan, which is difficult because you have small scale houses. So you have to be aware of different possible sizes of elements. And you need to be sure that in your main structure, that's already a given, that you don't have to make big changes in your structure by achieving that. Pure logics, but anyway, I'm telling. And we're working with a frame which you could activate or maybe not activate. It can it has a huge impact on can have a huge impact on the energy, the temperature, raise the TO. If you use it smartly, it could be outdoor space, but you can also say you can grow in it in a certain sense, which is also important element. And to get to the digits, And this Jordi van Laar has made this based on the case we did it. And you have to start with realizing that if you make a proper circular building, then you have to be aware. Your goal is that the separate elements or modules have a certain rest value the moment you have to update it. So what I told about a facade element, you need to update it since performance needs to be better, for example. Then it should have been designed in a way that it could be taken off in different elements. The beauty of timber structure is, of course, that's why we try to align those things, is that in general, it's easy and makes sense to have dry connections anyway, which makes remountability easy. But you can put different rest values to different elements. If you start calculating a model calculation over a certain lifespan, what we try to show, I can't go too much into deep, is the over a 50-year lifespan, what is the value of the real estate? It's important because investors are also now starting to realize if we build something now, we need to be aware of the value in 50 years, and thus we have to build a circular building. That's the narrative we want to tell, because if you see this graphic, it shows the traditional, say, carbon-based building in gray, which might make sense in the beginning. It's the challenge we always have as architects, trying to prove that the initial investment is not key for a proper long-term business case, because every jump you see in this graph means a certain life cycle of a certain element, and if it loses value over time, you lose value in your property. But if the elements you have to update keep on having a rest value, the overall value of your building relatively, of course, grows. So you also lose less money in the building. A beautiful example is the city of Rotterdam already is acting. They have buildings which are circular enough. Their conclusion is, after a few years, that they have less maintenance costs, and therefore they say, okay, then also the rents should go down. And that's where I want to go towards. So if the business case is smart and everybody's happy and everybody earns enough, then affordability could also be a goal to achieve. We're moving forward with this research now, so you will be hearing more of that. I want to end up talking about the latest tender we won together with Barcode Architects in Rotterdam, and ABC and Earthwhy as developers, investors. Shortly showing it, it's on a new built Sluisbuurt. So here's the center of Amsterdam on the left, and in the heart, one of the first plots is the one we will be designing. In general, it's a stack of 8 blocks to create a smaller korrel, a smaller block, which fits in a more inclusive city. It's an image from the water side. It's a very multi-use building. So on the ground floor, there's a commercial space, a supermarket. We make a huge ramp which goes up to the first floor, which has a huge amount of space for cycling. So in this neighborhood, foot and cycling is the key way of mobility. We see co-working, we see sports space, and the rest of it is housing. Showing the basic principle of the whole building. Yes, we still have a concrete basement. We now assume, because we need to make also a realistic business case, concrete course, but we are researching it now, and we see this open building with a huge framework, as I told earlier. So those lessons we want to really put in this building, and mass timber floors. In detail, what you see happening here, it's challenging because we also need to keep into account the biodiversity. So we need to create buildings which need to carry a lot of water and soil, because we want to have this this biodiversity in the city as much as possible. So enough challenges to achieve. We see here the entrance showing that people can walk up with their bikes. You see here the wooden main structure, and that's closing off this beautiful image of Sant & Co, showing that every space we can use, we want to and need to make it climate adaptive in that sense. Still having too much solar panels, if you ask me, but it's needed because it's an energy productive building. There was my last slide. I found those 4 images of the beauty of wood. For me, it was a beautiful final slide. Thank you for listening to my words.